from the Vietnam National University. And it represents some power IoT researchers.
My director, Professor Xuan-Tu. So, like, said our activity on travel power IoT research. It is the outline of my talk. So first, I would like to introduce a little bit about the Vietnam National University System, and then our working group. We call it Smart Integrated System Working Group, and now we turn to the Center for Integrated Circuit and Application. And next, I would like to introduce our research direction for IoT from the top level, and then after that, we introduce on IoT, for example, on the hypersecurity, a tech chip that can perform the full IoT system. I present also a kind of sensor that do not use ADC at all. Okay, and then finally, I would like to show some of our ongoing research on FAI for IoT. So first, I would like to introduce about our team. So first is Professor Xuan-Tu Tran. So actually, he graduated from France in 2008. He did his PhD in Seralati, Minatech INPG. And right now, he's a full professor at VNU, Hanoi. And he have a lot of work on network on chip, asynchronous design, and also the project that I present later. And he have quite a lot of publication, PhD student, and yeah, a lot of master student. And for me, I also graduated from France, from Grenoble, University of Grenoble, Alpes. And my research interest is on hardware software co-design, Internet of Things, artificial intelligence accelerator, cryptographic accelerator, and some on a new open injection set computer architectures, RISC-V, and Linux multi-core programming. Yeah, and I have been looking for the university for a long time, and yeah, it's in 2021. So actually, I moved to a new organization inside VNU, Information Technology Institute. And there is some of the some of the tech chip that we met. So this is one of our first tech chip that we met with Professor Tran in 2015. It is the one that I met during my PhD in 2017. It is one of the projects that we did at VNU on our own on IoT security for IT. So for the VNU system, it's quite complicated. In Vietnam, actually, there are only two Vietnam National University. One is Hanoi, so that's why we call Vietnam National University Hanoi. And the two university have two different government boards. So it means that we have two presidents, one for Ho Chi Minh City, one for Hanoi. And for VNU Hanoi, so we actually VNU is a consortium. It contains multiple university and research institute and some affiliated school and some research center, some research center and some service also. Yeah, so there is about staff. So there is the more recent one. We have near more than 5,000 staff. Among them, near 3,000 is actually academic staff, and the number is increasing because now we have more students. Like this number of the student is near 80,000 students. Most of them are actually graduate. There's a very small number is actually graduate study, and we have quite a lot of international students. And then we also host some French internship. Some people from France to our laboratory for internship also, and also from USA. So in the next 3 years, VNU is trying to build a new campus in Hua Tech Park with the area of very large one. It's about 11 kilometers square. It will be High Tech Park, which is 30 kilometers from Hanoi city center. Our campus, our working place is still in the city center, and it is the vision. Maybe you can see it in the next 3 years. If in the next 3 years you visit it, maybe we can bring you to our new campus. Now it's mostly flat because it's still under construction. This is my team, so it's led by Professor Xuan-Tu Tran, and we have some other professor working with us. For example, Professor Nam Kang-Dak from University of Aizu in Japan, and Professor Ziyang now is in another university. And we have a PhD student working on various subjects, for example, on security for IoT, on FAI acceleration, on autonomous UAV, and of course some other graduate students working on different subjects. Our main focus is on hardware security and security hardware, domain-specific accelerator for image and video processing, artificial intelligence, and also do a demonstration on FPGA. And recently we expand our research on some analog mixed signal. It's an analog circuit, but actually based on digital standard cells that we can use digital flow to do the design and layout. This is some of our facility. The latest technology that we have is the TSMC 65 nanometer PDK, and we soon have TSMC 16 nanometer technology. We have a lot of FPGA kit to make the demonstration. So yeah, our lab is not only do research, we also make some demonstration using different kind of FPGA kit. This is some of our collaborators. A lot is coming from France. Some are from Italy, from Japan, and there's some company that help us to fabricate and to do the design. And we also take part in very active in solid state circuit society and also CAS society. So recently we are actually helping CAS with the UniCAS program. It's the universalization of IC design in CAS. We call it UniCAS. So actually my team help to make education material. You can send it here, and you can also take some certificate from the CAS micro-learning. So actually this is a program that help you to use open source tool to design and then fabricate the chip. So you can design the integrated circuit using open source tool and then fabricate the chip. This is the one from the 2023 edition, and this is the one from 2024 edition that have been integrated by us. But there's many other more. And so for the IoT and main research direction, so this is how we think about the IoT. So the IoT is actually a system that contains a sensor and actuator, and they have wireless communication. Mostly, it may need very low power and long range, and then these sensor will collect the data, send through a gateway to the internet and to the cloud computing. So the internet backbone and cloud computing might have a lot of research already. But what about the sensor and actuator here? So so you can see that most of the IoT device now use a battery or even no battery at all. So that's why we focus on the sensor, ultra low power sensor, so that it can work with for a long time with the battery. And later I will present some systems that don't use a battery at all. So from that system overview, so this is our main research direction. So first, the IoT, we need computation so that it can send some data through the network. So that's why we also focus on some IP design or microprocessor design. Next is IoT collect our private data, so it needs security. And so that's why we, from my start of my PhD, I did a lot of work on the ultra low power data encryption. And of course, it needs low power so that with a very small battery can work for maybe 3, 5, or even 10 years. And the last one is, so most of the IoT device now might need to be smart. So it means that we need to integrate some AI inside. But to do AI on the app is another challenging topic. So it lead to some of our work during the past. So one of the first one is the ultra low power cryptographic kernel that I did during my work in CLT. So at the time, so when we talk about security, so actually it's data encryption. So one way to protect our privacy is just encrypt the data from the source and then send through the network and then do processing somewhere else. So that's why we create a design combining one traditional security algorithm, which is AES, and a lightweight one is present into the same design. And then we try to have some technique to optimize the power consumption. You can read more about this technique in this paper. And this has been designed and fabricated in STFPSOI 28 nanometer. So actually we perform power optimization for the critical part of the design, and so it can support multiple block size and the key size from lightweight one to a very high level one. And I use a special data path of 32 bits for AES. Yeah, and this is the system design. This is the test chip layout, and this is the test system, and this is the measurement. So actually, with the test chip, we can have the very low energy of 0.4 picojoule per bit when you want to do encryption using AES, and it can have very high throughput if you need high throughput design. And however, at high throughput, of course, it consumes much more power, 2.2 picojoule per bit. And there is some comparison with the other work. So I focus on the 32-bit data path here. So I think that the energy consumption is very low. And after that, so when I come back to Vietnam, so actually we do another project that do the whole system with not only the cryptographic kernel, but also with some RISC-V processor. So that is the ADEN for IoT tech chip. So this is the idea. So in general, we design a system on chip with some data encryption inside, and then we have the transceiver interface. At the time, we choose to use Bluetooth Low Energy or LoRa, and then we have interface with the sensor through some I2C or ZPIO or some other method, and then the system will collect the data, do the data encryption in place, and then send it through a gateway and then to the cloud. This is the system organization. So we have a RISC-V processor. We design some data encryption hardware, co-simulator, co-processor, and then yeah, we do all the step to the tape out. Yeah, this is some information about the design. It's called the authenticated encryption with the associated data. And this is the test system on FPGA. So it contains everything. This is a transceiver. This is transceiver, the antenna, and this system is put into the FPGA so that we can test the functionality before fabrication. And this is the programmer, so that we can program the system from the computer. And this is the layout for the tape out. And this is the whole system demonstration. So when the chip come back, we make the PCB, we connect with the sensor, and we put it outside Hanoi for testing. And at the time, the weather is too hot, so we have to make this to protect it from the rain, and also have air circulate inside so that we can measure the PM 2.5 or PM 10. And we make a simple application to display it. And after that, we continue with the project, but this time we do not fabricate the chip. We make the full platform, and we also make the cloud and the mobile app so that it can display the data. Yeah, and recently we are collaborate with a professor in Japan, Professor Koichiro Ishibashi, on some new design. We call it the bit sensor. It's some kind of sensor that do not use ADC at all. So the idea of the bit sensor is the value that you measure is actually proportional to the time that the signal is transmitted. So there is no ADC at all. So the system is organized so that, for example, in this example, it's we measure the temperature. So each device will broadcast an ID signal, and the time between different transmission is proportional to the value that it is measured. Yeah. So for example, in this case, the time between two transmission is 2.1 seconds. So it means that somewhat low temperature, and if the time is long, it can be high temperature. And so we do some data processing to interpolate it into the temperature value. Sorry, I do not have the picture of the system, but in general, it is a new kind of sensor that do not use ADC. We only use a microcontroller to control the transceiver to send some signal, and there's a circuit that will charge and discharge the storage capacitor. So when the value is measured through a storage capacitor, when the system charge the capacitor to some level, it will turn on the microcontroller to send it to send the value. And we also add data protection with data encryption to that system, and it's still under the bucket of the storage capacitor. Yeah. So this is the organizer of the system. This is a photovoltaic. This is a storage capacitor. This is a resistor that normally it's the measured value will be proportional. The time will be proportional to the time charging the capacitor, and this MCU is only for transmit the IF signal. And we do the measurement in our campus. Yeah. And the last part is on our design on Edge AI. So this is some of our ideas. So our current AI deployment model is we have data set, we do the training, we have the model, we put it on a server, and on the IoT device, we collect the data, send to the server, and then the server do everything. The problem with this is the device have to send it to the server, so it will take the bandwidth. And what if there's a problem with the data transmission, for example, no power, for example. So our idea is put the model or part of the model to the device, and after that we can do data processing on the device. And maybe we can send back some data to the server to do the conclusion. So our idea is to do hardware-software co-design. So model, it depends on what kind of platform. We will divide it into two parts. One is the part that will be done in hardware, and some part will be done in software. The part that take time and maybe easy to compute, we put to the hardware so that it will increase the throughput. Some part which is very hard to do in hardware, we do it in software, so it's easier and more flexible. This is some of our work on the map, the multiply and add. So we use static computing or a variable bit precision, and we make a complete system. And this is some of the hardware resources. To do the hardware-software partitioning. So we can make it into a more flexible platform that can generate the code for different platforms, for example, CPU, GPU, or our custom accelerator. And it is some of the design that we use high-level synthesis. It is a variational autoencoder that has been designed into in C++ using VT's high-level synthesis. Yeah. This is one of our student work, and you can see this is for the abnormality detection. It can detect something abnormal from some image. Yeah, and to conclude, so I think that right now there's so many chances. There's a lot of open source project that we can reuse, so we can do the design faster. There's the new open source EDA tool. So this create a new chance for us. For example, for people from Vietnam can learn and then can contribute to the society. This is one of the projects that we do using only open source tool. Yeah. And this is the timeline for our lab. So we are trying to make a chip for the power energy harvesting and maybe an AI chip in next year. So thank you very much.
Thank you for your presentation. As we are running a bit out of time, we may have time for only one short question. If nobody has one, I have one.
Yes.
You said that you use 28 nanometer DSI from ST Microelectronics, I guess.
Yes.
Why do you use this technology?
So So at the time, ST make the advertisement that it's the one of the good technology for IoT because it have the it use SOI wafer, and actually the device have actually lower power leakage. Yeah. So it's so in other process maybe you will have a big problem with the leakage, but on the SOI wafer the leakage is normally smaller, and actually you can use backbiasing to control the speed or control the leakage. Yeah.
So thank you again.
Thank you.